Got it? So now let's do this question. See, this was the question from AIET 4. All right. So first of all, this is a very good question and a bit of tough also. The coefficient of x raised to the power 20 in 1 plus x, 1 plus 2x, 1 plus 4x, 1 plus 8x and so on, 1 plus x raised to the power 20x. So first of all, there are so many things to notice. What? There are total 21 brackets. How come? See, it is like 1 plus 2 to the power 0 into x, 1 plus 2 to the power 1 into x, 1 plus 2 to the power 2 into x, and so on. It is going up to 1 plus 2 to the power 20 into x. Correct? So, this is how it is. 1 plus 2 to the power 0 into x, 1 plus 2 to the power 1 into x, 1 plus 2 to the power 2 into x, 1 plus 2 to the power 20 into x. Correct? Now, take 2 to the power 0 common. So, you get 1 plus x as it is. Then you take 2 to the power 1 common. You get 1 by 2 plus x. Then you take 2 to the power 2 common. That is x plus 1 upon 2 square. And so on, 2 to the power 20 common, x plus 1 upon 2 to the power 20. Am I correct? Now, it will be 2 to the power 1 plus 2 plus 3 up to 20 into x plus 1, x plus 1 by 2, x plus 1 by 2 square, and so on, x plus 1 upon 2 to the power 20. They're asking for coefficient of x raised to the power 20. Now, first of all, I'll talk about this. Sum of all the roots will be what? Sum of all the roots will be minus 1 by 2 minus 1 by 2 square and so on minus 1 upon 2 to the power 20. Am I correct? And what exactly sum of root means? Coefficient of x to the power 20 upon coefficient of x to the power 21 with a negative sign is now apply sum of roots here. This admin, am I audible to you? Whoever is there from the admin, am I audible? So this will be what? Apply the sum of GP. So that would be take minus common 1 plus 1 by 2 plus 1 by 2 square and so on 1 upon 2 raised to the power 20. So it is A 1 minus R raised to the power 21 upon 1 minus 1 by 1 minus R, that is 1 minus 1 by 2. Now this whole will also be multiplied by this because this is getting multiplied with every term. But so we will do it later on. So now it is what? It is take it like a coefficient of x to the power 20 in this. See, I'm considering in this. So coefficient of x to the power 20 is 1, see, 2 minus 1 upon 2 to the power 20. Got it? Now in the overall expression, in this expression, what will be coefficient of x to the power 20 will be, now we multiply by 2 to the power 20 into 21 upon 2 into 2 minus 1 upon 2 to the power 20. So it is 2 to the power 210, 2 minus 1 upon 2 to the power 20. So 2 to the power 211 minus 2 to the power 190. This is going to be your answer. Am I correct? Have a look at it. Though it's a bit difficult, but I think you can absorb it. Now, the second question in this paper was given x plus y plus z equals to 3. X plus y plus z equals to 3. Then another information we have is x square plus y square plus z square equals to 5. And another information we have is x cube plus y cube plus z cube is equals to 7. Correct? Now x plus y plus z equals to 3, x square plus y square. See, one relation I have that x plus y plus z whole square is equals to x square plus y square plus z square plus twice of xy plus yz plus zx. Correct? So this xy plus yz plus zx will be 9 minus 5 by 2, that is 2. So one information is clear. Now another information that we have is x cube plus y cube plus z cube minus 3xyz will be x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Got it? So x cube plus y cube plus z cube given to you as 7 minus 3 xyz is equals to x plus y plus z 3 x square 5 minus 2. So it is 9. Got it? So xyz value will be minus of 2 upon 3. Now we have to find out x square plus y, x power 4 plus y power 4 plus z power 4. Now this is what? This is x square plus y square plus z square whole square minus 2 times xy square plus yz square plus zx square. Am I correct? Now this is what you already have, and now this is quite a task to identify. So this is x square plus y square plus z square whole square is 25 minus 2 times. Take it as a square plus b square plus c square. That is a plus b plus c whole square minus twice of ab plus bc plus ca. So if I write that xyz common, it will remain x plus y plus z. So it is 25 minus 2 times xy plus yz plus zx whole square, that is 4 minus 2 times xyz is minus 2 by 3 into x plus y plus z given to me as 3. Correct? This 3 cancelled. So it is 25 minus 2 times 8. So 16, 25 minus 16, this answer goes 9. Am I clear? So this is just simple algebraic identities you have to use again and again to get through this. Now see, assuming the balls to be identical except for difference in color, the number of ways in which one or more ball can be selected from 10 white. So they're given to you as 10 identical white, 9 identical green, and 7 identical black. So here I'm writing their total ways of selection. Now understand this, there are 10 identical white balls. So total ways of selection will be what? 11. How come 11? Like I do not select any ball, that is a choice. So that is one way. I select one ball, that is also a way, one way. I select two balls, again one way. I select three balls, again one way. So there will be total 11 balls from not selecting anything to selecting everything. So here, total ways of selection of 10 identical white balls is 11. Then total ways of selection of 9 identical green balls is 10. Then total ways of selection of 7 identical black balls is 8. So total ways of selection will be 11 into 10 into 8. But see, one thing is there in the question, one or more ball can be selected, means at least one ball is what you are supposed to select. So I subtract away minus 1 where we do not select any ball. So answer will be 880 minus 1, that is 879. Got it? So this was the question. Now another one. Okay, one more thing I would like to tell you. Had in this question been 7 identical, say everything is fine, but they also include, say, 6 distinct, say, blue balls. Now there are 6 blue balls who are distinct. So if I include that 6 distinct blue balls, in that case, ways of selection goes 2 to the power 6. Means n distinct objects, then the total ways of selection will be 2 raised to the power n. Got it? So in that case, your answer will be 11 into 10 into 8 into 2 raised to the power 6 minus. Then we will go this way if it has been like this. Got it? Now, A is given to you log 5 base 4 and B is given to you log 6 base 5. They are asking for the value of log 2 base 3. All right. See, this log 5 base 2 outside came 1 by 2 is equals to A. So log 5 base 2 is 2A. This can be written as log 2 base 5 plus log 3 base 5 is B. Now log 5 base 2 is A, means log 2 base 5 is 1 by 2A. So 1 by 2A plus log 3 base 5 is B. So log 3 base 5 is B minus 1 upon 2A. that is 2ab minus 1 upon 2a. They are asking for log 2 base 3. Now you divide both of them. So log 2 base 5 upon log 3 base 5 is 1 by 2a divided by 2ab minus 1 upon 2a. So 1 upon 2ab minus 1. This Delhi is the answer. But 1 upon 2ab minus 1. Now, see, few questions we'll do here only. Number of shortest path from point A to point D as shown in the figure. So in this diagram, they're asking for the total number of shortest paths from A to D. Now, how the person will go? So if approaching from A to D, first of all, he'll go from A to N and then N to D. Then he'll go from A to M and then M to D. And see, this path M to N, it has been calculated twice because A to N, then N to M, then M to D. This has been calculated while you are going through N and going through M twice. So we will subtract that. Got it? So required ways will be A to N to D or A to M to D. And now from this I will subtract the ways A to N to M to D. Now A to N will be 1, 2, 3, 4, 5, 6. See, 2 horizontal sticks, 4 vertical sticks. So 6 factorial upon 2 factorial, 4 factorial multiplied by N to D, that is 5 factorial upon 2 factorial, 3 factorial plus. Now A to M. A to M will be 7 factorial upon 2 factorial, 5 factorial into M to D, that is 4 factorial upon 2 factorial, 2 factorial. Now from this subtract A to N, that is 6 factorial upon 2 factorial, 4 factorial multiplied by 1 multiplied by M to D is 4 factorial upon 2 factorial, 2 factorial. Why I subtracted this? Because this path from N to M has been counted twice. So you have to subtract it. Got it? Now if you solve it, this is going to be 126 plus 7. This is 150. 150 plus 126 minus 90. So your answer will be 186. Got it? Now see the next question. Yeah, this is an easy one. If A and B belongs to R such that AB is less than 0, then under root A under root B is equals to. Now see, product AB is less than 0. Am I correct? So that means one of them is positive and the other one is negative. So just to make your understanding better, I will first of all go with simple numerical example. Got it? Let A is minus 2 and B is 3. So under root A under root B. That is under root of minus 2 under root of 3. Got it? Take this as under root of minus 1 under root 2 under root 3, which can be written as iota times under root of 2 into 3, or I can say iota times under root of magnitude of individually. So similarly, you can write under root of A under root of B is iota under root of magnitude of A magnitude of B. Modulus of A or modulus of B we can say. So this will be your answer. Got it? Now, and let's see the 67 question of trigonometry. The question is sin x plus sin y is equals to A and cos x plus cos y is equals to B, then sin of x plus y and C. All these things they are asking. So, first of all, there are two separate ways to find these things. Got it? So, first of all, what I will do, square and add. Square and add. So, if you square it, it is 1 plus 1 plus twice of cos x minus y. It is a square plus b square. So cos of x minus y is a square plus b square minus 2 upon 2. Now in all the options they are asking tan of x minus y by 2. So it is 1 minus tan square x minus y by 2 upon 1 plus tan square x minus y by 2 is equals to a square plus b square minus 2 upon 2. Now let's do one thing, apply componendo dividendo here. So here I am doing denominator minus numerator. So you get twice of 10 square x minus y by 2. So it will be 4 minus a square minus b square. In the denominator, I will do numerator plus denominator. So here comes 2 and here it will come a square plus b square. Correct? This 2 cancel. So 10 square of x minus y by 2 is 4 minus a square minus b square upon a square plus b square. So either this option is correct, Delhi, or this option is correct. Now I will have to check for sine of x plus y. Now how do I get sine x plus y? See, if you apply sine c plus sine d in the first equation, what do you get? 2 sine x plus y by 2 cos x minus y by 2 is equals to a. In the second equation, 2 cos x plus y by 2 into cos x minus y by 2 is equals to b. If I divide both of them, I get tan of x plus y by 2 as a upon b. Got it? Now, what do you want? Sine of x plus y. That is 2 tan x plus y by 2 upon 1 minus tan square x plus y upon, sorry, 1 plus. So it is 2a by b upon 1 plus a square upon b square. So that would be 2ab upon a square plus b square. Got it? So 2ab upon a square plus b square. Ahmedabad and A option is going to be the correct answer. Have a look. This is a very good question. Take a look. All right. Now, find a number of real solutions of this question. See, this is very simple. A thing must to do. If you cancel both of them, 1 upon x square minus 4, so you get x equals to 2 as a solution. But since the question has 1 upon x square minus 4, so you cannot put x equals to 2 because at this point denominator will get 0. Am I clear? So denominator getting 0 means this solution we got is also rejected. So that means no solution. Now, if the coefficient of x square and x cube in the expansion are equal, then see simply what will be the coefficient of x square? X square will be 9c2 3 raised to the power 7 kx square. This is equals to x cube that will come from 9c3 3 raised to the power 6 kx cube. Got it? So it is 9 factorial. Directly I will write 9 into 8 upon 2 into 3 is equals to 9 into 8 into 7 upon 3 into 2 into 1 into kx. And see, they are talking about the coefficients only. So this x writing is not important. Got it? So 9 into 8 cancel. This 2 also cancel. So your k will be 3. 9 upon 7. See, negative answer, no question rises about that. So that is what we can neglect just by seeing in the very first. Got it? Now, xn is z equals to x plus iota y, magnitude of z squared less than equals to 1 by n. Then they're asking for x1 plus x2 plus intersection of x1, x2, x3 and so on. Now see, n belongs to natural for all integers. See, if n is 1, if n is 1, what is x1? x1 will be magnitude of z square less than or equals to 1. That means, so that implies magnitude of z less than 1. Am I correct? So that is what? All the points lying inside the circle with center 0, 0, radius 1. Now, if n is 2, then this will be magnitude of z square less than equals to 1 by 2. Implies magnitude of z is less than 1 by unknown caller. So magnitude of z square less than or equals to 1 by 2. So this is a circle with center as again 0, 0, radius will be 1 upon 2. Similarly, if n is 3, so magnitude of z square less than or equals to 1 by 3. So it is a circle with center as 0, 0, radius 1 by 3. So this is how it is going. So if ultimately if n goes very large, it will be magnitude of z square less than 0. Equality so I cannot include. So it taking intersection of all of them, what it will be? So it will be no common point there in all of them because this is what we have no idea what it is. See, x square plus y square equals to 0 will not be counted here. Because, and even if it goes very large, whatever the large it is, it will never go 0. Got it? So it will be a, so it should be an empty set. I think answer key, in answer key it is given as singleton set, which should be corrected. Got it? Now, the fractional part of 2 to the power 78 upon 31. So what do you require? You require the remainder when 2 to the power 78 is divided by 31. What do you want? A remainder when 2 to the power 78 is divided by 31. See, we have something related to 2 to the power 5, which is 32. So 2 to the power 5 raised to the power 15, 75, and then 8 times. So I write it 8 times, 32 raised to the power 15. So that is 1 plus 31 raised to the power 15. So remainder when 2 to the power 78 is divided by 31 is 8. Remainder when 2 to the power 78 is divided by 31 is 8. So if that is so, fractional part will be 8 upon 30. This is our answer. Am I correct? Fraction part is 8 upon 31. Now, this is done. Now come here. See this question. This is a simple question. This is 18C15 plus 18C16 plus 18C16 plus 17C16 plus 1. Correct? See, this 1 can be written as 17C17. So their sum. Now we have an identity NCR plus NCR plus 1 is N plus 1 CR plus 1. So this will be what? 18C17. Now 18C16 plus 18C17 will be what? 19C17. Now 18C15 plus 18C16 will be what? 19C16. Finally, 19C16 plus 19C17 will be what? 20C17. And that will be 20C3. 20C3. So your answer will be Bombay, that is 20. Correct? Now, this is a simple question you will manage. Now we'll talk about 75. 75, they are saying 10 times sin to the power 4 alpha plus 15 times cos to the power 4 alpha is 6. So 10 times sin to the power 4 alpha plus 16 times cos to the power 4 alpha is equals to 6, isn't it? 10 times sin to the power 15 times cos to the power 4 alpha is 6. 15 times is equals to 6. So in such kind of question, first of all, what we do? Divide by cos to the power 4 alpha. So 10 times 10 to the power 4 alpha plus 15 is 6 times 1 plus 10 square alpha whole square. So 10 times 10 to the power 4 alpha plus 15 is 6 times 10 to the power 4 alpha plus 6 plus 12 times 10 square alpha. Correct? So it will be 10 times 10 minus 6. 4 times 10 to the power 4 alpha minus 12 times 10 square alpha plus 9 equals to 0. So it is 2 10 square alpha minus 3 whole square equals to 0. Implies 10 square alpha is 3 by 2. So we got this. Am I clear? Now 10 square alpha is 3 by 2. So I can say secant square alpha is 5 by 2, which is 1 plus 10 square alpha. So cos square alpha is 2 by 5. So sin square alpha will be 3 by 5. Now we have sin square and cos square, both the values we have, you just put them there and get your answer. Got it? Now in the binomial expansion, the ratio of 7 term from the beginning and 7 term from the end is 1 by 6, then value of n is. Remember one thing, rth term from end is n minus r plus 1th term from beginning. Got it? So if they are saying 7th term from the beginning means T7 is equal to 7th term from the end means upon. Now that would be n minus 7 plus 1 means n minus 6 term. So T n minus 6. And this ratio is given as 1 by 6. Got it? Now, A is xy, y is e to the power x, b xy, y is e to the power minus x. Then A intersection B or A union B, they are asking. See, y is e to the power x. See, e to the power x is having this kind of graph. And e to the power minus x will be having this kind of graph. So there will be 1 point common. So A intersection B is not 5. There is only 1 point common. Point is quite visible. It is 0, 1. Am I clear? Now, if some 3 consecutive coefficients in the binomial expansion of this in powers of x are in ratio 2 is to 15 is to 70, then the average of these 3 coefficients is, see, you should take NCR, NCR plus 1 and NCR plus 2. Now their ratio is given to you as 2 is to 15 is to 70. Got it? Now 79, let SR is, this is 11, x more than equal to R, y more than equal to R, z more than equal to R. Then number of elements in SR. All right. See, what will be S2? S2 will be x plus y plus z equals to 11, where x, y, z all more than equals to 2. So this is something like you want to distribute 11 identical oranges to 3 beggars x, y, z such that you give at least 2 orange to every beggar. Got it? So do one thing, distribute 2 orange to every beggar first of all. So you gave basically 6 to them, then you are left with x plus y plus z equals to 5. Now non-negative integral solution of this equation is 7c2, correct? Now S3, while calculating x plus y plus z equals to 11, and then you want to give 3 oranges to every beggar at least. Got it? So first of all, do one thing, give 3 to them. They are saying x, y, z more than equals to 3. So 9 already distributed, you are left with 2. So if you are left with 2, that means x plus y plus z equals to 2. Answer will be 4c2. Now S4 is x plus y plus z equals to 11 and x, y, z all more than equal to 4. This case is not possible. Got it? So 7c2, 21 and this is 21 basically and this is 6. So 27 will be the correct answer. Correct? Now, see this question. If the LCM of P and Q is this, where R is are prime numbers and PQ are positive, then number of ordered pairs PQ. See, this is a question from previous year JE. Undoubtedly a good question. Then how do we do it? See, R is are prime numbers. So out of P and Q, at least one should be having R to the power 2 necessarily to get R square in the LCM. So it is like if it is P, it is Q. Either it is having R square, R ki power 0, R square, R to the power 1, R square, R square. Then again R to the power 1, R square, and R ki power 0, it is R to the power 2. So total 5 cases with respect to R. Similarly, with respect to T, if you will see, there will be total 9 cases. And with respect to S, again 5 cases. So answer will be 5 into 9 into 5, that is 225. Got it? So, like this question 85, x square, sum of all the real numbers satisfying this equation. You just take 2 cases. While x is more than 1, it is x square plus x minus 2 equal to 0. So x equals to 2, sorry, factors will be x plus 2 into x minus 1 equal to 0. So one root will be acceptable, that is x equal to 1, if I include 1 here. Now if x is less than 1, it will be x square minus x equal to 0, then roots will be 0 or 1. 1 you already counted, 0 is also you have to count. So there are only 2 roots, 0 and 1. Right? Both are accepted. Alright, so there are a few more questions which you should attempt definitely. And this is a good paper. That would be all. Thank you so much.